This is not my this presentation is not mine. I present on behalf of Ebru Aktekin. She is not here because of some medical problems, some health problems. I present. My name is Mohammed. I am PhD student in Boğaziçi University in Istanbul. I started 2 months ago in September. So I am new in this research area in physics, in astronomy actually. The title is Optical Supernova Remnant Search in Nearby Galaxy NGC 6946. Supernova remnants are the aftermath of stellar explosions which injects material at very high velocities into interstellar medium. After such explosions, strong shock waves are formed. They create objects called supernova remnants, which results in ionizing, heating, and forming new structures in the interstellar medium of the galaxy. In order to understand the properties of SNRs, supernova remnants, they can be observed in optical, X-ray, and radio bands. So in this presentation, I focus on the optical observations. Here in summary, the shock waves, the nebulae is shocked in shortly. And in interstellar medium, there are some regions that is composed of ionized hydrogen clouds and free electrons. We call these regions H2 regions. Two means singly ionized hydrogen. In optical search, these regions is very important because in optical search, hot gas is easily observed in the optical region of the spectrum. Gas that is largely ionized produce emission lines from transitions to lower energy states. And also hot stars produce large flux of ultraviolet photons will photoionize hydrogen, which producing a region of singly ionized hydrogen. And we call that photoionized nebulae. That's why we call H2 regions. And we have a criteria for distinguishing shocked nebula from photoionized nebula. S2 lines, which means singly ionized sulfur lines, are relatively weak as compared to H-alpha lines, Balmer lines in H2 region. For supernova remnant, as a result of shock waves from the explosion, S2 lines are stronger relative to H-alpha lines than in an H2 region. And this gives the possible identity of the region. If the ratio of the S2 to H-alpha flux ratio is greater than 0.4, it's possibly supernova remnant candidate. If it's less or equal than 0.4, it's likely H2 region. So this is our selection criteria for the supernova remnant candidate. And also, I forget, the bracket notation here means forbidden line, which is a transition from a metastable state. In low density environments like in a nebulae, collision times become much longer and electrons can remain in a metastable states undisturbed before spontaneously decaying to lower energy states. In Earth, we cannot observe these lines because density is relatively high. And in this work, results of optical imaging and spectroscopic studies for the detection of possible remnants in a nearby galaxy NGC 6946. We we make image analysis and determined the supernova remnant candidates, and showed one of the candidates spectroscopic study of one of them is shown in this presentation. And this is some properties of our galaxy. Nearby spiral galaxy NGC 6946 is one of the most actively star-forming galaxies in local universe. 10 supernovae have been observed up to now, and therefore this galaxy should contain a large number of supernova remnants. And first optical search for CNRs was made by Matonic and Fessen 1997. And the recent detailed study for optical search using narrowband imaging was done by Long et al. Last year with the Wien telescope, and they determined 89 SNRs using our selection criteria, and these SNRs are spectroscopically confirmed. This is the characteristic of our telescope. We used Russian and Turkish telescope, RTT 150, and diameter is 1.5 meter, which is the biggest optical telescope in Antalya, Turkey. And their specifications are given in the table. And this is our data. Interference filter characteristic and exposure times of imaging observation are shown in the table. Hydrogen alpha, hydrogen continuum, hydrogen alpha, singly ionized sulfur, and their continuum filters are used, and we have 3 different observation times: 2015, 2017, 2018. We have 3 different observations. And in the slide, I present the procedure to make analysis for the detail reduction. We use IREF package in order to clean images. We eliminate some bias corrections or scan fields and cosmic rays to make the images cleaned. And singly ionized sulfur and H alpha subtraction are performed because we could subtract the stars and produce pure emission line images. Then using our selection criteria, we get the images. This is our images. Here is the combined hydrogen alpha images of our galaxy. 3 hydrogen alpha images are combined here. And face on and spiral parts are clearly seen. Here, 95 CNR candidates are determined in these images. We determined 95 CNR candidates, and I show you one of the spectroscopy of one of the candidates. And for the spectroscopy analysis, we use low resolution faint object spectrograph camera, TFOX we call it. We get 16 spectrum measurements, but here I present only one spectrum here, which is observed in 2 years ago with the given exposure times. And spectral measurements were obtained in the range of these wavelengths with the Grism G15, whose dispersion of 8 angstrom per pixel. Iron-argon calibration lamp frames were obtained for slit with the 100 micron for observation. And this is the ore spectra, or one of the candidates spectra. Position of the candidates are given here. This is we determined from the ore image analysis. And lines, hydrogen alpha, hydrogen beta lines, and the other forbidden lines, singly ionized sulfur, singly ionized nitrogen, doubly ionized oxygen lines are clearly observed. Here as our selection criteria, the ratio of the singly ionized sulfur to hydrogen alpha, here the ratio is 0.52, which means is larger than the 0.4, or selection criteria is satisfied here. So we confirmed spectroscopically or CNR candidate. We determined in the image, and also we spectroscopically confirmed here. This spectra is not confirmed in the long study. Long et al. Last year, very detailed study. It is not confirmed here. We confirmed spectroscopically the same SNR candidate here, and we use the lines to some parameter. We can calculate some parameters using the lines, using the emission lines, electron densities, shock velocities. These parameters we can calculate from the spectrum. For determining the shock velocities, we use these lines, doubly ionized oxygen and hydrogen beta lines. For the electron density, we use this ratio. This is the summary of the everything. The ore selection criteria is 0.52, intensities, shock velocities, color excess, and the other electron densities or the other parameters are given here. And the results, in this work, we present the optical study for CNR candidates. We determined 95 CNR candidates, and one of the spectrum is shown here and spectroscopically confirmed first time. And I finish. Thank you. This is Boğaziçi University in Istanbul. This is the two continents are here. This is the European side. This is the Asia side. Thank you.